Okay. So we have this problem. We want to find the slope, a couple of slopes. And that corresponds to a couple of rates of change. Now, if you're in my class, you have a test. Okay. And you have to be able to do these things. So, at least if you want to do well on the test. So take this as a lesson there, but this is also what your homework is over. Okay. So between, okay, on the interval 1, 2. If t equals 1, what is y? And if t equals 2, what is y? Oh, can you tell me, can you show me with your fingers? Fingers in your hand? Okay. Are you asking a question or are you saying it's 1? No, obviously saying it's 1. Okay. If t equals 1, y equals 1. I mean, that's what the point 1, 1 tells you. Okay. The point 1, 1 tells you that, well, if t equals 1, y equals 1, we can draw the lines, horizontal and vertical line through the point. And this point is y equals 1. On this line, y equals 1. On this line, x equals 1. And make sure you understand that. And then on this vertical line, x equals 2. Now it's getting smushed up. I didn't write that very well. Oh, here x equals 2. And that's really bad too. Okay. And up here, well, what's the equation of this line? Can you write down what the equation of that line is? Okay, people had some trouble answering the question, what's the equation for this line? Now, we've been talking about the equations of horizontal and vertical lines since almost the first day. And I'm not saying you're at fault here, just saying think about the fact that if you didn't understand it, and most of the pre-calculus class probably didn't understand it, because y'all are doing pretty well here. And then the idea, and I should say this in pre-calculus class, and I hope some of them would actually look at these videos, but because a lot of people need them. If you didn't understand that, somebody should have asked the question, either one of you or somebody that's actually in the pre-calculus class. So this is very important. So I'm going to just isolate these 2 points. And what do the coordinates of the points tell us? 1, 1. And 2, 4. Okay, among other things, the coordinates here, 1, 1, and coordinates of the point 1, 1 mean y equals 1, and x equals 1. If these points are on the graph, this tells us that f of 1 equals 1. If you call this function y equals f of x. Okay. And this function happens to be the toolkit squaring function. This is the function actually in this case it's f of t. We're using t instead of x. Okay. And what's the formula? It's not x squared, now it's t squared. Okay. In other words, we square the value of 2, we get 4. We square the value of 1, we get 1. We square the value of 1/2, we get 1/4. We learned to construct this without having to do that algebra and that arithmetic for reasons people coming in pre-calculus class don't know what the square of a negative number is. Often, a significant number of students want to tell me that the square of -2 is -4. So we started with the construction. Now we've moved from the construction and we're talking about formulas. Okay, so there are two things this tells us. And if these are points in the graph of y equals f of t equals t squared, this tells us that, of course, f of 1 equals 1 squared, which is 1. We have all this information from the point that this is the point 1, 1. Also, that this point lies on the vertical line. Okay, this point is on the vertical line, x equals 1, and the horizontal line, y equals 1. I've said it many times, make sure you lock it in. Every point on this line has x coordinate 1. That's why it's the line x equals 1. Every point on this line has coordinate y equals 1. And that has an advantage if you've got this axis scaled, and if you've got both these axes scaled, you know that this is where x equals 1 and this is where y equals 1. Okay, well, 2, 4 tells us similar things. It tells us that the point is on the vertical line, x equals 2, and on the horizontal line, y equals 4. If there's a vertical line, x equals 2. Here's the horizontal line, y equals 4. Y equals 4 when x equals 1, or f of 2 equals 4. And of course, f of 2, I don't want to write anything there, but you could also write f of 2 equals 2 squared, which of course equals 4. All these things from the point 2, 4. Now the picture tells us very clearly that the run goes from x equals 1 to x equals 2. And from x equals 1 to x equals 2, the displacement is 2 minus 1, which is 1. Also, that the rise is between the line where y equals 4 and between the line where y equals 1 and y equals 4. We'll say it in that order. Okay, so the rise is 4 minus 1, which is 3. Now, I've drawn this picture. I drew this picture in the pre-calculus class. So those of you who are in my pre-calculus class will have already seen the picture. Okay, and when you calculate the slope, I really want you to make this picture with all the horizontal lines and all the vertical lines, because it'll stick with you better than a formula. Now the formula, well, first of all, let's calculate now the slope. And it's 3 over 1, not 2 over 1. And I put a rectangular box around the slope. So now I can just look at my picture and see how the slope was calculated. Okay. and what the slope is. And I won't confuse that 3 if I got a box around it. I won't confuse that 3 with the distance. The distance from here to here is found by the Pythagorean theorem, which I hope you remember. Okay. But we're not talking about the Pythagorean theorem right now, so I'm not gonna do that. Now, definition. Formula. Now it's y2 minus y1 over x2 minus x1. That's a formula everybody remembers, at least for a short term and maybe for a long time. But now the variable here is t. So we're going to make it t2 minus t1 instead of x2 minus x1. And y2 is 4, y1 is 1, so it's 4 minus 1 over run, which is x2 minus x1, which is 2 minus, or t2 minus t1, which is 2 minus 1, which is 3 over 1, which is 3. Okay. The formula will get this for you without ever invoking a picture. So if all you want is to calculate the slope, the formula is just fine. But I don't like the idea of using a formula without understanding it when that's possible. And you have a very informative, but reasonably simple picture here that if you practice drawing, will show you what the slope is and why it is, and also give you a picture of what it means that's going to be very valuable for you when you take a calculus course. The slope formula doesn't tell you any of this. You have to connect the formula with this. And I like the idea of starting with this and then seeing what the formula tells us, rather than starting with the formula and trying to interpret it here, but you can do it either way. Okay. That's the slope. Now I'm going to ask you to make a little bigger picture of this graph. You know, I haven't shown you that you can do this, but it works out for the squaring function at least. Okay, if I draw a picture of my squaring function here, but now this square is 1 unit this way and 2 units this way. Then I ask, what are the equations of these 2 vertical lines that I just drew through the right and left edge of my rectangle? Okay. And remember, the rectangle is not a 4 by 4 rectangle anymore. It's a 2 by 1 or 1 by 2 rectangle. Okay. So the distance between these points, these lines, has to be 2, right? Because that means it tells you right there. Okay. And the y-axis, which is actually should be a little bit more to the left, but we understand that we've got a red dot here in the middle of the lower edge. Right, this is right in the middle. So what's the x value of every point on this line? What's the x value of every point on this line? We don't have a 4 anywhere in this picture. And I'm asking for the vertical line, x. And what is x here? And what is x over here? Let me pause here and see how you're doing. Okay, now again, I emphasize you should be able to draw this picture because I've drawn it a number of times. Kind of make note of that. If I've drawn it, then you really ought to at least flip through the videos. And if you see something that you don't understand, you need to try to focus on understanding it, okay? It's hard to get people to understand the need for that, they never have. Okay, so anyhow, this is y equals 1, because this thing has a height of 1. Here's where y equals 0, that's on the t-axis. And here's where y equals 1, because 1 unit above the t-axis. All the points in this line are 1 unit above the t-axis, meaning that they all have coordinate, y-coordinate 1. Okay. Now, I wish I'd have drawn this a little more accurately, but if we subdivide this thing like so, then of course we would subdivide it even further. But if we cut this thing in half, remember, if you move over 1, you move down 2 lines. Well, if I do my usual construction, then I've got this line and this line. It's identical to the construction that we learned for the toolkit scaling function. Okay. Except that now the labels are different. So maybe it isn't even a scoring function, but in this case it is. Okay. Maybe it's 2 t-squared, or maybe it's 1/2 t-squared, but this would be t a picture for t-squared. Okay, so what would this be? Y equals what? What would this be? So just kind of, this line cuts this rectangle here in half. This line cuts the whole rectangle in half, and then this line cuts the lower rectangle in half. Just as you do when you construct scoring function. Okay, so people got this very nice. So this would be y equals 1/2. This would be y equals 1/4. So what are the coordinates of this point and this point? Once you have the coordinates, how do you get the rise? How do you draw the rise and the run between these points? Okay, not everybody's doing as I recommended. I didn't do it here. I didn't draw the x equals 1. I didn't label the x equals 1 or x equals -1 lines. Okay. And then what's this line? Because I want a vertical and horizontal line through each of my points. So I know where I am. So I know clearly where I am. So the vertical line through this point has what equation? Well, if x equals 1 here, x equals 0 on the y-axis, which is something we always want to remember and understand. Okay, this is halfway between 0 and 1. What's halfway between 0 and 1? It's 1/2. So now I write the coordinates of my points. Okay, this point here is 1, 1. Because it's on the line where x equals 1 and the line where y equals 1. That's actually t equals 1. I should use t instead of x. If you slip up and use x, always doesn't cause confusion. I don't have a problem with it. But let's go ahead and be correct here. This line would be t equals 1 since my x-axis is now labeled as t-axis. Okay, so t equals 1/2 here, and y equals 1/4. So this is the point. 1/2, 1/4. Now, we draw a little arrow indicating the run, and we draw a little arrow indicating the rise, and we make sure that that arrow takes us from one point to the next. Okay, and usually I say the leftmost point to the rightmost point. So the run will always be positive. It'll always go to the right. Then you have to figure out whether the rise is positive or negative. Okay. Well, here's the triangle. So what's the run? How far does the thing run? The recording button has been malfunctioning, but so have I, so I don't know whose fault that was. Okay, so we did this over here. Again, I said 1/2, 1/4. If you want the run, you're going from the vertical line where x equals 1/2 or t equals 1/2 to the vertical line where t equals 1. And then your run is going to be 1 minus 1/2, the later minus the earlier. And 1 minus 1/2 is 1/2. The rise goes from the horizontal line where y equals 1/4 to the horizontal line where y equals 1. And that distance is 1 minus 1/4, which is 3/4. So your slope is the rise divided by the run, which is 3/4 divided by 1/2, which is 3/2. And we put that in the box right here. And then we put a box over here to indicate that the meaning of that 3/2 is slope. Just in case you're a little fuzzy in the calculations, 3/4 divided by 1/2. Well, we can write that 3/4 / 1/2 means 3/4 divided by 1/2, which is 3/4 times 2/1. Multiply that out, 6/4, and that reduces to 3/2. All right, so we've got that slope. Now, what I really am wanting to get to, and the whole purpose of this exercise, at least main purpose, is to talk about what the slope could mean. So I'm going to draw my original picture here. And we're going to go back to what I demonstrated. That this graph represents motion of something that moves 1 foot in about 2 seconds at a uniform acceleration. That's physics, you don't have to know that. So let's see, 1,001, 1,002. Yep, took just about 2 seconds to get from here to here. Now, if you look, 1,001, we're right here. Okay, so 1,001, we moved this far. So that's a quarter of the way from here to here, because halfway would be here, quarter of the way would be about here. So if they move 1/4 of the distance, and then move 3/4 of the distance. Now, in coordinates, if this is in feet, this graph is in feet, and we said that originally, and t is in seconds, y is in feet, t is in seconds. We went 1 foot in 2 seconds. In 1 second, we went 1/4 of a foot. And we can see that again. Here we go, 1,001, 1,002. Okay, that far, 2, 3, 4. Okay, we went 1/4 of a foot. That's 3 inches. If you want to do this in inches, you can do it. You have to change your function of it. Okay. Multiply all your y values by 12, and you get inches. It might be worth talking about. Okay, well, here we've got it, and we've got this point, and we've got this point. And these points are 1, 1, 1/2, 1/4, and 2/4. Of course, the coordinates that we get when we mark this thing off agree with the fact that this is y equals t squared. If t equals 1/2, what's 1/2 squared? It's 1/2 times 1/2, which is 1/4. So if you square 1/2, you get 1/4. So that gives you the point 1/2, 1/4. Of course, if you square 1, you get 1, so the point 1, 1. And on the original graph, if you square 2, you get 4. So we got the points 1, 1, and 2, 4. We've also got the point 1/2, 1/4. This picture gives a close-up of these two. It's got an enlarged picture. Well, we've got these points and we have calculated the slopes. For this, between these 2 points, the slope was, where did I label it? 3. And here the slope was 3/2, and it's really poorly written. It's 3/2 there. So let's just ask what the rise means. The rise from 1, 1 to 2, 4 is 4 minus 1, which is 3. You know what? I've been saying that this represents most 1 foot in 2 seconds. And certainly no better. I don't know why. Okay, watch this. 1,001, 1,002, 1,003, 1,000. Okay. It's 2 feet in 4 seconds. That makes sense? Watch it again. 1,001, 1,002, 1,003, 1,004. Okay. If I counted seconds correctly, and you do all kinds of physics with this, in the physics class, it's learned to do that. So we went 1/2 foot in the first second. Well, that's the meaning of the point. Sorry, in the first second. Oh, wait a minute. Actually, this represents something that goes 4 feet in 2 seconds. Now, confused the whole issue. I couldn't do that. I actually have. Well, I thought I had it right here. That doesn't work. Okay, we're talking about 4 feet in 2 seconds, and I'll get this right. Okay, so 1,001, 1,002, 1,003, 1,004. Okay, that's 4 feet in 2 seconds. I'll let the thing run right off the end. 1,001, 1,002, 1,003, 1,004. Well, it slowed down because I dropped it. You get the idea. Okay, so now that we're oriented, we can interpret this. What does the 4 represent? Well, first, what's the 2 represent? 2 is the t coordinate, right? And what's t measured in? Okay, so what's the meaning of 2, 4? 2 is the t coordinate, t is in seconds, right? So we could remind ourselves that t is in seconds and y is in feet. You can pick a picture of that, but y is in feet, t is in seconds. So the 0.24 says the distance is 4 feet, which t equals 2 seconds. What does the 0.11 tell us? And the 0.11 tells us the distance is 1 foot after 1 second. Okay. Now the rise is 4 minus 1 equals 3. 4 what? Minus 1 what? Okay, the camera, or no, that wasn't the camera, Zoom, just chose to randomly stop in the middle. Probably because I was careless when I hit the button, but it never said that it stopped. And I hold that against Zoom. Okay, I like Zoom pretty well, but I wish they'd get that little glitch fixed. It's just, there's a big delay when I press the buttons and it's a little confusing. I'm learning. And that delay is kind of new. It wasn't happening earlier. Okay, anyhow, so we asked the question again, what is the meaning of the 4 minus 1 equals 3? Well, the 4 represents 4 feet along that ramp, okay? And the 1 represents 1 foot. So we went from a distance of 1 foot to a distance of 4 feet. The 4 minus 1 represents how far we went between those two times. It's 4 feet minus 1 foot, and 4 feet minus 1 foot is 3 feet. And everybody understands it. It's 3 feet, not 3 seconds, not $3, okay, not 3 kilograms or whatever. Feet minus feet gives you feet. Run is 2 minus 1 equals 1. Now, what does that mean? Let me pause if I can. Okay, so slope is rise over run. We've established that the rise is 3 feet, not just 3. The run represents 1 second, not just a number 1. Okay, so if we do the units, we got 3 feet over 1 second. Now 3 divided by 1 is 3. And we've still got feet divided by seconds. Okay, so it's 3 feet over seconds. Feet over seconds. Does that invoke any kind of a recognition? Okay, so I got a very interesting and very nearly correct answer in this. Somebody told me that this feet over seconds was miles per hour. Well, that's not really true because feet aren't miles and seconds aren't hours, but that's the exact connection we want to make. If you put miles over hours, you read that as miles per hour. Okay. If you put feet over seconds, by analogy, you mean feet per second. Okay. And that means that between here and there, this thing was traveling at an average speed of 3 feet per second. Okay. Let me set these aside someplace where I won't get hurt. You'll probably get hurt with those there, but I'm leaving the full size. Okay. So which is 3 feet per second. Okay. whenever you calculate a slope of a meaningful quantity, it's going to have units of whatever the rise is, in this case feet, divided by whatever the run is, in this case seconds. So it's going to be like units of rise per unit of run. Okay. You're always going to get something over something. It's always this per that. So if I had a graph of how much money you have in your account, okay? Now everybody's got what, $5 or $6 million in their account right now. How much you're going to have in 10 years? Okay, let's just say you're relatively poor and you've only got $3 million in your account. Okay. If anybody has $3 million in your account, I'm very happy for you. Okay. If you go from $3 million to $7 million, how many $1 million what was your change? It's $4 million. That's obvious, right? And if you do that in 10 years, then how many dollars is that per year? Don't say it. And you're like, well, you could do it with a gesture. If you divide 4 by 10, you get 0.4. Okay. So you get $0.4 million per year. That's how much your account increases by. That's $400,000 a year, which isn't bad money. Okay. Make sense? That's the meaning of slope. Because if you have a graph of your money versus time, it looks like this. What kind of a function is that? Okay. If this is your money, and if we assume that everybody's got $3 million in their account right now, and this is t equals 0, then this point could be 0, 3 instead of 0, 1, as it would be if this was a toolkit exponential function. But everybody recognizes this has the shape of the toolkit exponential function. Now, if we go out to this point, okay, let's say you're earning 7% interest on your money. Then there's a simple rule that we'll see when we study exponential functions. This tells you it takes 10 years to double your money. Okay. So if we go out to this point, what do you think t is here? Give me 2 digits. Like if you think it's 55, you go 5, 5. Okay. So if t is 10 here, what's t here? 13. Okay. Actually, I think it's more than that because t is 0 here and t is 10 here. How long is that? This is 10. So it looks like 20. And that actually looks to me a little bit more like it's 21. Okay. It's a little more than twice as far from the origin as this. So this line is t equals 21. This vertical line is t equals 10. And we see that they're pretty much evenly spaced with t equals 0, right? So we can put t equals 0 here in the y-axis. So we go 0, 10. I said 21. The way these things are run, thinking maybe it's closer to 20, but I'm going to go with 21. I don't want to use too many round numbers. Okay. Now, what's the y-coordinate here? It's the y-coordinate of this point. 3. Okay. 0.03. So everywhere on this horizontal line, y equals 3. Really make sure you understand that, because it's really kind of central to understanding what graphs are telling you. Okay. Now, if y is 3 here, what do you think y is here? How many 3s does it take to get up here? How many times further is this from the t-axis than this? 5 times? Okay, so let's say that's 15. I actually know it's 11.7832, but I don't like to show off my ability to answer things. Okay, seriously. Okay, if we go from y equals 3 to y equals 15, I'm sorry. Okay, this point is 0.3. Let's calculate it here. Now I'm going to say if this is 15, that's a little less than half, so we'll say y equals 7 here. We can now quickly get the triangle that we need to calculate the slope. The run is 11 because it goes from 10 to 21. I don't have room to write it all out and we're out of time. So in the rise is 15 minus 7. So the slope write $1 million, a million with a dollar sign, so we'll have to read. The run is 21 years minus 10 years. That comes out $8 million over 11 years, which is approximately 7.3. Sorry, 0.73 million dollars per year, which is $730,000 per year. So that's how much money you're making on the average between year 10 and year 21. Just an example.